Hi, this is Jack from Maths Forge, and in today's lesson we're going to be doing recurring decimals to fractions. So for our first example, we're being asked to convert 0.2 recurring to a fraction. How do we approach this? Well, we're going to use algebra to help us with this. The first thing that you do is that you assign a variable of x to the recurring decimal. So it's going to be x is equal to 0.2 recurring. And I'm just going to write 222 so you can see what's happening. The next thing we do is we ask ourselves, what can I multiply by this number here on the right to get one set of the recurring value or values to the left of the decimal point? Well, in this case, it's times 10. And what that means is that if we multiply it by 10, do we get the recurring value to the left-hand side of the decimal point? So the recurring value here is just 2, and multiplying by 10 gets one of the recurring values to the left of the decimal point. However, the recurring values still go on forever. Now, because we multiplied the right side by 10, we have to multiply the left side by 10 to keep the equation balanced. And 10 multiplied by x is going to give us 10x. So now we're left with two equations. X is equal to 0.2 recurring and 10x is equal to 2.2 recurring. The next thing to do here is to subtract one equation from the other. The larger equation from the smaller equation. I'm going to do 10x minus x. So I'm going to do the left-hand side minus the left-hand side. And this is going to allow me to do the right-hand side, so 2.2 recurring, minus the right-hand side here, 0.2 recurring. And if you can see what's going to happen, the recurring values will cancel each other out. The 2 minus the 0 is going to leave us with 2. The 0.222 recurring is going to cancel out with the 0.222 recurring, leaving us with nothing after the decimal point. And on the left-hand side, we're going to have 10x minus x, which is going to leave us with 9x. And now if we just rearrange for x, so I'm going to divide both sides by 9. This will leave us with x is equal to 2 over 9. And if you remember what we actually assigned to x at the beginning of this question, we said that x is equal to 0.2 recurring. Well, if x is equal to 0.2 recurring, and x is also equal to 2 over 9, therefore 0.2 recurring must also be equal to 2 over 9. So 0.2 recurring as a fraction is 2 over 9. And if we check our answer, there it is. Now, I know some of you who had the lesson on converting fractions to recurring decimals would have just said, well, hang on, if it's just 0.2 recurring, then it's just going to be 2 over 9 because there's one recurring value, and we know that recurring values are written over 9 or 99 or over 999. That may be. However, this method here that I've just explained, you're going to be able to use it to solve any problem that's given to you on converting recurring decimals to fractions. So it's a very important method to learn. Now let's do a 2-star example. Here we're being asked to convert 0.583 recurring to a fraction. So we start off in the same way. We assign the value of x to 0.583 recurring. We now ask ourselves, what do we have to multiply by this value here on the right to get at least one of the recurring values to the left of the decimal place? And in this case, it's times 1,000. And we have to do the same to the left-hand side, times 1,000. This is now going to give us 583.3 recurring. Because if you think about it, after the 3, there are just going to be more 3s. This is the only value here that's recurring. And on the left-hand side, it's going to give us 1,000x. Now at this stage, if I decide to do 1,000x minus x, it's going to give me 999x. But if I do 583.3 recurring minus 0.583 recurring, it's not going to give me a whole number. It's going to give me a number with a decimal point. And you might think, well, what's wrong with that? Remember for the first example, when we rearranged for x, it gave us a fraction. We must try and avoid using decimal numbers in fractions. So how do we actually go about solving this problem then? Well, since the 1,000x and the x are incompatible, you can't actually subtract them from each other without getting a decimal number, we're going to go ahead and multiply something else to this x to get it into a position where we can subtract it from the 1,000x. So now I'm going to write out my x equals 0.583 recurring again. And instead of multiplying it by 1,000, I'm just going to think, what can I actually multiply this by to get it into a position where there is only a 0.3 recurring after the decimal point? And the answer to that is multiplying it by 100. If I times by 100, we're going to end up with the following. 100x on the left, and on the right, we're going to end up with 58.3 recurring. So even though the 1000x and the x were incompatible, so these two equations here, if you actually think about what's going to occur now, this 1000x and this 100x, these two equations here, are compatible with each other. If I do 1000x minus 100x, I end up with the following, 900x on the left-hand side. And on the right-hand side, we're going to have to do, so 1000x is represented by 583.3 recurring, minus 100x, which is going to be 58.3 recurring. And of course, 583 minus 58 is going to give us 525. And the 0.3 recurring minus the 0.3 recurring is going to cancel out and give us nothing. So now we're going to be left with 900x is equal to 525. And if we divide both sides by 900, we end up with the following. X is equal to 525 over 900. And if we simplify this final answer here using a calculator, 525 over 900, this is going to give us the following. 7 over 12. And this should be 0.583 recurring as a fraction in its simplest form. So if we check our answer, there it is, it's 7 over 12. Now we'll do a 3-star example. We're being asked to convert 0.285714 recurring to a fraction. So the first thing I'm going to do is assign an x to it. So I'm going to say x is equal to 0.285714 with a recurring point over the 2 and the 4. I'm now going to ask myself, what can I multiply by this number to get all of the recurring values to the left of the decimal point? And in this case, it's going to be times 1 million. Because of course we have 1, 2, 3, 4, 5, 6 digits after the decimal point that's recurring. So we're going to need a 1 with 6 zeros. And I have to do the same to the other side, times by 1 million. Now this gives us a million x, which is equal to 285,714.285714 recurring. And now let's just think if this is going to be compatible. If we subtract the x from the million x, what will we get? We'll get 999,999x on the left. And on the right, we're going to have 285,714 minus 0, which is going to give us 285,714. And of course, this decimal value here will cancel out with this decimal value here, leaving us with zeros. So the two equations are compatible. Now dividing both sides by 999,999, this is going to give us 285,714 over 999,999. And using a calculator to simplify this, this is going to give us the following, 2 over 7. So 0.285,714 recurring is going to be 2 over 7 as a fraction. And if we check our answer, there it is.